Aloha! Welcome back. Here we are in Unit 6 with our fourth lesson, and we're going to be solving these root equations. It might be square root, it might be cubic root, whatever, but we're going to be solving these equations, and we're also going to throw in some inequalities that we need to solve. So how do we solve those square root and cubic root equations and inequalities? So the one thing that we really need to remember when solving an equation is that we do have to check for an extraneous solution. And you may have heard of the word extraneous, but if you haven't, the word extraneous is, it's just like not, even though we do all the math correct, it just doesn't work when we put it back into the equation. So it emerges, like the definition I'm reading, it says it emerges from the process of solving the problem, but is not a valid solution to the problem. So it's kind of strange that that could happen, but you'll see when and why we get extraneous solutions. So here we go. We're just going to jump on in. Example 1. Notice we just have like kind of one square root or one cubic root, but we're solving this. So we're going to solve for x or whatever variable is there. So we want to isolate that variable. So I need to get to that x in example 1. So the first thing I'm going to do is I'm going to actually divide by 2 on both sides. So that gives me the square root of x plus 2 is equal to 4, because 8 divided by 2 is 4. Now, how do I get to the x? Well, there's a square root in my way. So to undo the square root, I'm going to square both sides. Squaring a square root gives me just what's underneath. Squaring 4 gives me 16. And now all I need to do to solve for x is subtract the 2, and I get x to be 14. I do want to check to make sure that is not an extraneous solution or not. So I'm going to plug 14 back in. So 14 plus 2 is 16. The square root of 16 is 4. 4 times 2 is 8. So that means it is correct. All right. Let's try it again with b. This time it's a cubic root. We still need to isolate that cubic root in order to get to the x. So the first thing I'm going to do is add the 2. So now I'm taking the cubic root of 2x minus 5 equaling 5. And now I need to cube both sides, because how do I get rid of a cubic root? I'm going to cube it. So when I cube the left, I'm just left with 2x minus 5. 5 cubed, or 5 to the third power, is 125. And now I'm just solving for x. Add that 5 and divide by 2. And so I get x to be 65. I want to make sure that that is an answer, not extraneous. So I would plug it in and check my work. So really I'm taking the cubic root of 2 times 65 minus 5 minus 2, and does that equal 3? Well, 2 times 65 is 130. 130 minus 5 is 125. The cubic root of 125 is 5. 5 minus 2 is 3. So yes, that is correct. All right, let's do it again. Now it says we have the square root of 2x plus 7 is equal to x minus 4. So notice for a and b in example 2, we have x's on both sides. So same process, but a little bit different because we do have those x's on both sides. So in a, my square root is already isolated. So how do I get to the x on the left-hand side? Well, I would need to square that square root. So squaring the left-hand side just gives me that 2x plus 7. Squaring the right-hand side gives me x minus 4 squared. We should know by now that that is not x squared plus 16. That is x squared minus 8x plus 16. And so now you should be able to solve for x. Put everything on one side, set it equal to 0, and you can then factor, use quadratic formula or completing the square, whatever. So if I set it equal to 0, I have x squared minus 10x, and then that would be plus a 9. So are there factors of 9 that add up to negative 10? Yes, that is negative 9 and negative 1. And then I know that my answers here would be x is 9 and x is 1. So then I want to check, are either one of them, both of them, extraneous? So let's start with the 9. So I'd be plugging in square root of 2 times 9 plus 7 equals 9 minus 4. So 2 times 9 is 18, 18 plus 7 would be 25. The square root of 25 is 5. And does that equal 9 minus 4, which is also 5? Yes. So this is a right answer. Now let's try 1. 2 times 1 is 2. 2 plus 7 is 9. The square root of 9 is 3. And then this is now 1. What's 1 minus 4? A negative 3. Does 3 equal a negative 3? No. So that means 1 is an extraneous solution. Okay. Let's try it again. Square root's already isolated, so I need to square both sides. It's going to give me x squared plus 2x plus 1. Set it equal to 0 and solve for x. Are there factors of negative 14 that add up to negative 5? Yes, that is going to be a negative 7 and a positive 2. So that means x is 7 and x is negative 2. I want to check to make sure that they are not extraneous. It could be one extraneous, it could be both extraneous, it could be neither extraneous. So I plug in the 7. Square root of 7 times 7 plus 15 is equal to 7 plus 1. Well, 7 times 7 is 49. 49 plus 15 is going to be 49. Why can't I do math right now? 49 plus 15 is, 64. Square root of 64 is 8. 8 does equal 7 plus 1 because that's also 8. So that means 7 is a solution. Now let's try 2. So 7 times 2 is 14. 14 plus 15 is, 14 plus 15 is, why can't I do math right now? 29. 29, square root of 29, does that equal 3? No. Oh, hold on, my bad. Hold on. Miss Treese, what the heck are you doing? It was a negative 2, not a positive 2. Well, that'll change it. All right, let's try this again. It's a negative 2. All right, 7 times negative 2 is negative 14. Negative 14 plus 15 is 1. The square root of 1 is 1. Does that equal negative 2 plus 1? No, because negative 2 plus 1 is actually negative 1. So still an extraneous solution, but closer that time. We want to make sure we're putting in the right x value, Miss Trees. Come on. All right, let's try this again. Example 3. So these, very similar to example 2, a little bit more complex this time. So what I would do for these is you're going to have 2 square roots here. So that's kind of the issue. And I would actually have one on one side and one on the other side. So in A, I have my right-hand side square root isolated, but the left-hand side is not isolated. But if I go to isolate the left-hand side, then the right side won't be isolated. So we're good right now. What we need to do is we need to get to those x's. And in order to get to those x's, we have to work to get to underneath the square root. So we need to square both sides. So if I'm going to square both sides, I'm going to get on the right-hand side just 7 minus x. When I square that square root, I just get what's underneath. On the left-hand side, we need to be really careful. We are squaring the entire left-hand side. That means I need to FOIL this. First times first, well, the square root of x plus 6 times the square root of x plus 6 is x plus 6. But then the outers and the inners, that's square root of x plus 6 times 1, and then the square root of x plus 6 times 1. So that's 2 times the square root of x plus 6. And then last times last, 1 times 1 is just still 1. Okay, so now I can kind of move some things around. So what I can do maybe is subtract that x and subtract that 6. So I have 2 square root of x plus 6, and then also subtract that 1. So subtracting the x is going to give me a negative 2x. Subtracting the 6, subtracting the 1 gets rid of the 7. So now I'm here. I can divide by 2. And then what could I do here? I need to square both sides. Squaring the left, squaring the right. I am squaring a negative x. So that means I get a positive x squared. And so now I can set it equal to 0. And then I ask myself, are there factors of -6 that add up to -1? Yes, that's -3 and +2. And so then that means x would equal 3 and x would equal -2. And then, of course, I have to check those two. So I'm going to plug in to the original. Let me make this a little bit smaller. I'm going to plug into the original a 3, and then I'll see if it works, and then I'll plug in a -2. So plugging in a 3, 3 plus 6 is 9, square root of 9 is 3, 3 plus 1, that's 4. Does that equal 7 minus 3 is 4, so the square root of 4 is 2. Does that equal? No. Extraneous solution. Let's try the -2 now. -2 plus 6 is 4, the square root of 4 is 2, 2 plus 1 is 3. Does that equal 7 minus a -2 is 7 plus 2, which is 9. The square root of 9 is 3. Does 3 equal 3? Yes. So -2 is a solution and 3 is not. Okay? And let's do it one more time. So this time, remember I said it's easier to have a square root on both sides. So I'll have the square root of x plus 6. I'm going to add over that square root of x minus 2. So now I have 2 plus the square root of x minus 2. Okay, and then the same kind of concept here. I'm going to square both sides. Squaring the left just gets me x plus 6, but squaring the right, I have to FOIL that, right? So first times first, outer and inner, and then the last. Move some things around. So subtract the 4, add the 2. That's going to give me 4. Subtract the x, so that cancels out. Divide by 4. Square both sides. And then solve. Easier to solve for this one, but I still need to check that solution. So if I plug in 3, 3 plus 6 is 9. The square root of 9 is 3 minus 3 minus 2 is 1. The square root of 1 is 1. 3 minus 1 does equal 2. So yes, it is a solution. Okay, now we're going to get into those fractional exponents. So we'll have to rewrite it as a root possibly, but we're going to solve kind of the same exact way. So I'm trying to get to the x, so I need to isolate that x. So what I would do first is I would subtract my 2, and then I would divide by 2. So I have 2 times 3x to the 3/4 power equaling 16, divide by 2. So now that's 3x to the 3/4 power equals 8. Well, if I rewrite this, this is the 4th root of 3x to the 3rd power equaling 8. And so now what I can do is I can get rid of that 4th root on the left-hand side by raising it to the 4th power. Well, if I raise the left-hand side to the 4th power, I also need to raise the left-hand side to the 4th power. 8 to the 4th is a big number. It's 4,096. And that's not something that I would expect that you know off the top of your head. And then now we just need to take the cubic root of both sides. Cubic root of 3x cubed is 3x. Cubic root of that 4,096. Again, I know that's a big number. I'm not expecting you know that, but it is 16. And so then dividing, we just get x to be 16 over 3. Now, we do need to, we unfortunately do need to check that, but don't get too confused yet or scared yet, because when I plug it in for x, I get 2 times 3 times 16 over 3, and then raised to the 3/4 power plus 2 equals 18. So let's see if that works. Well, what's 3 times 16 over 3? It's just 16. 16 to the 3/4 power, so the 4th root of 16 cubed. Well, the 4th root of 16 is 2. 2 cubed is 8. So what's 2 times 8? 16 plus 2 is 18. So it is a solution. Okay. All right, and then let's do another one. So first thing I would do is add the 60 to both sides. And I would maybe rewrite this as the square root of x plus 3 cubed. How do I get rid of the square root? Well, I would square both sides. Remember, this is an understood 2 there if you want to write it. Oh, that should be a 3. My bad. Square both sides. 64 squared, that big number, 4,096 again. And then take the cubic root of both, which we just did, was 16. And then subtract the 3. And so then we want to check, is that a solution? Well, if I plug it in, 13 plus 3 to the raised to the 3/2 minus 60 is equal to 4. 13 plus 3 is 16. The square root of 16 cubed. Square root of 16 is 4. 4 raised to the 3rd power is 64. 64 minus 60 is 4. So, yes, it is a solution. Okay. Now we're going to go to those inequalities. So kind of the same process, but it just says, remember, in addition to your solution, an even root must be greater than or equal to 0. Remember, when I take the square root of something, that something has to be positive. I can't take the square root of a negative. I can't take the 4th root of a negative. So this is what they're talking about here, that even root must be positive. It must be greater than or equal to 0. And then it just says, be careful when you're looking at the square roots greater than or less than a negative. A square root will always be greater than a negative. A square root will never be less than a negative. So just remember that. So let's get to solving. And we do want to write our answer in interval notation, it says. All right, so first thing I would do in example A is I would add that 4 over. So now I have 3/4 square root of x less than or equal to 12. Then I'm going to divide by 3/4, which is the same thing as multiplying by 4/3. So now I have the square root of x is less than or equal to 16. And then I square both sides. So I get x is less than or equal to 256. Okay. What I also need to take into consideration is because I have a square root, what is inside or underneath that square root must be positive. It must be greater than or equal to 0. So that x also needs to be greater than or equal to 0. So if I have these two inequalities to think about, if you need to draw that on a number line like 0 and 256, I want x's that are greater than or equal to 0. And then I want x's that are less than or equal to 256. So where do they overlap? Between 0 and 256 included. So that would be my final answer. Okay, let's try it again. In this one, I would divide by 2 first. So I have the cubic root of x plus 1 is less than 4. Now I'm going to cube both sides. And then I'm going to subtract that 1. And then this time, remember, I had the cubic root of something. It doesn't matter what's underneath a cubic root. It could be positive or negative, right? It's only when I have an even root. So this is my final answer. I want the x's that are less than 63. So that's everything from negative infinity to 63, not including. Okay. All right. Isolate that square root so we can get to the x. So subtract the 3 first, then divide the 3. So 3 square root of 2x minus 1 greater than 9. Divide by 3. Square root of 2x minus 1 is greater than 3. Because I didn't divide by negative, so my sign doesn't change. Square both sides. Add the 1. Divide by 2. Okay, so then I need to double check. Well, did I have an even root? I did. So what's underneath that even root has to be greater than or equal to 0. So then I also need to say that 2x minus 1 has to be greater than or equal to 0. So then I say, well, then that's 2x is greater than or equal to 1. So x is greater than or equal to 1/2. So I need to make sure that my final answer is true for both of those things. So again, if you need to write a number line, 5, oh, let me put 1/2 on this side, and 5. So I wanted x is greater than or equal to 1/2. So solid dot greater than or equal to 1/2. And then I want x is greater than 5. So open dot and greater. Where are they both true? Here. So that's starting at 5, not including, and going all the way to infinity. Okay? And then let's look at C. On C, we have our square roots isolated, and they're actually isolated on both sides, but because we have it on both sides, we need to square both sides, which is going to be nice, though, because when I square the left, I just get my 5x minus 16, and when I square the right, I just get my 2x minus 4. And so now I just put x's on one side, numbers on the other. So subtracting that 2x, I get 3x. Adding that 16, I get 12. Divide by 3, I get that. Well, this time, though, we got to think about this. I have 2 even roots. So what's underneath the first one needs to be greater than or equal to 0. So 5x is greater than or equal to 16. So x is greater than or equal to 16 over 5. And 2x minus 4 has to be greater than or equal to 0. So 2x has to be greater than or equal to, 4. And then x is greater than or equal to 4 divided by 2, which is 2. So now I have to take into consideration those 3 things. So 16 over 5 is a little bit bigger than 3. So I have the 2, I have the 16 over 5, and then I have 4. X is x is less than or equal to 4. So everything over here. X is greater than or equal to 16 over 5. And then x is greater than or equal to 2. So where do they all overlap? Right here. So from, let me make this smaller. So our answer is from 16 over 5 to 4, including both. Okay? Draw your number line. All right, and then the last 2. Sorry, hold on. Okay. All right. So I want to isolate the square root. So dividing by a negative is going to change my sign. So now I just have the square root of 2x minus 3 is greater than a negative 3. Pause right here and let's think about what this is saying. When is the square root of any number greater than a negative number? Always. Always. Okay? But here's the kicker. We still need to incorporate that what's underneath that even root has to be greater than or equal to 0. So this is always, and this is x is less than or greater than or equal to 3/2, then that means my answer is 3/2 to infinity. Okay? You can't just get here and stop, because this still needs to be greater than or equal to 0, because if that was a negative, then it wouldn't be no real solution. So you got to think about that, okay? And then look at the f. It's the same exact problem, but the sign is flipped. So when we divide, we flip the sign again. So now that 2x minus 3 is going to be less than negative, not negative 4, negative 3. And so then I think about this. When can the square root of a number be less than a negative? Never, right? No solutions. So you need to be careful when you're working with square roots, when you have it greater than or less than a negative number, because it could be something like E or it could be something like F, and you don't want to do all the math and it just be something like that. So yeah. Hope you are feeling good. Talk to you later. Bye.